Good morning, good afternoon, or good evening, calculus warriors. You're here with Cybercoin, who will walk you through this seemingly simple-looking calculus problem we have right here, but looks more often than not is deceiving. Here we are asked to integrate e to the power of 2x times cos 3x with respect to x. By looking at the form, we could already identify that the problem is an integration by parts problem. And I'm working under the assumption that you already know your detail, thus can already decide that e to the 2x will be your u and cos 3x in this case is your dv dx. Let's find out the derivative of u and antiderivative of dv dx, so that we are armed by these 4 pieces of info right here that we could simply put them into the formula. One certain to our constants so they can exit the integral, and now we're left with another complex form to antiderive with respect to x. But we will have no problem integrating it because it's pretty much in the same form as our original function. Again, we will collect possible information by deriving the u and antideriving the dv dx and insert them into the formula. And then simplify all multiplications, and we are now left with this large chunk of numbers, functions, and integrations. And looking at the last part here, it's in the same form as our original and second function, and our mathematical instinct would say that we can simply integrate it by parts again. Doing it will result in another complex forms that we could integrate by parts, in which if we integrate it again, it will again result in another complex forms that we could integrate by parts. And we're stuck in a deadly never-ending infinite loops of integration by parts, which I assume we don't want. Well, lucky enough for us that this form is exactly the same as our original form, so we could eliminate it later. Now we're moving on to the big part. First up, we're going to equate the original form with the result, and don't forget that this part over here is actually this whole part. So we'll substitute those values in, then we will do the multiplications. Simplify everything to base 9. Here we want to eliminate this last part, in which we don't want to integrate again by moving it to the left hand side. The thing that we have to remember though, the left hand side isn't actually empty. It contains this original function of e to the 2x cos 3x to integrate with respect to x, and because everything is in base 9, we'll put 9 over 9 in front since it's equal to 1. We'll move the integration to the left hand side, in which negative 4 over 9 changes sign to positive 4 over 9 and add it with 9 over 9, resulting in 13 over 9. And we will eliminate base 9 by multiplying the whole thing by 9. And to make left hand side go back to its original form, we'll divide everything by 13. And lastly, we're gonna want to simplify a bit more. And don't forget your plus C.